For the second experiment, we're going to be learning about atomic spectra. Atomic spectra is a way to describe specific colors of light that are produced by specific elements on the periodic table. In this case, a spectra can also be compared to a fingerprint in the sense that it is unique to an element. The word luminous just means that it's a light-producing fingerprint. If an object is hot and dense, like a star or the filament of a light bulb, the spectra are what we call continuous. And you can see a picture of a continuous spectra here that ranges from red to purple in the visible light spectrum. However, if an object is hot and rarefied, specifically low density like a gas, the spectra are discrete. So we're going to be looking at the spectra of gases. This can also be known as an emission spectra. The spectra of gases, you wouldn't actually see this black color, but you'll see the absence of color, and then you'll just see discrete bands of light like stripes, like the ones you see here. However, if an object is very cool, it doesn't emit light, it will absorb light because light is a form of energy. In that case, you would view an absorption spectra. So the colors of light that were produced in this top band are now being absorbed by a cool gas, and as a result, you can see all of the colors except for the ones that are being absorbed. So we're going to do an experiment where you observe the atomic spectra of a few elements, and the reason is it replicates the work of an early scientist, Niels Bohr, who came up with a model of the atom that we still use in class today. And this is a picture that's called the Bohr model that's based on his understanding of the atom. Niels Bohr observed that when you look at hydrogen gas that's been exposed to an electric current, it releases energy as light. You might remember doing a flame test experiment in class, and it was a similar concept, right? When metals absorbed the heat, they produced different colors of light. So in this case, instead of a metal, we're going to have a gas inside a tube, and we're going to put it in an electric power source. And as the electricity passes through it, it will emit light for the same reason that the metals emitted light in the flame test, because the electrons are being bumped up to higher energy levels by the energy in the electricity or the flame. And as they fall back down to their resting energy levels, they release that excess energy as light. Bohr used the same test in order to study elements and found that each element emitted its own distinct color of light. So he was able to study all different elements in the periodic table, and he noticed that they were unique. In addition to the fact that they were unique, he noticed that the bands of light were discrete, meaning they were separate. There was not a continuous spectrum like you might expect. The reason that they're discrete is because of the energy levels, which are discrete around the nucleus of the atom. So if you look at where the electrons are located, Bohr's discovery was the discovery that led us to draw an atom with these energy levels that surround the nucleus, but where each energy level is a little bit bigger than the one before it, and they are basically giving us an idea with the most likely location of the electrons in that energy level where they would be, how far from the nucleus. But they were not a continuous or random assortment of electrons. The electrons stay a fixed distance from the nucleus, and that was what Niels Bohr discovered through this experiment. You're going to use the experiment to help you identify some of the elements that he studied by looking at the colorful light that they produce using diffraction glasses. This QR code links to a website that will show you some other spectra, some similar to the ones you'll see in class and some different. There'll also be some cards that have the atomic spectra for the elements that we are studying in class. You can use those cards to help you identify them. For each tube, you should write down a label in the first column, the colors that you observed, and then the element that you believe is contained inside the tube. It's possible that some tubes might experience some leakage, but you can just write down what you observe and then pick the one that's closest of the choices that are given.